Okay, let's begin. So in this presentation, this is I think my 10th or 11th Minitab presentation. What I'm going to do is consider a manufacturing process, and in this process, the process is constructed in such a way that the mean measurement is 1001 units. Also, less than 2% of the measurements produced has a measurement of less than 1000 units. Okay, so what I'm going to do here is go to Minitab, and I have this little data set called manufacturing process, and I've opened this straight up from the CSV file, so that's what it should look like when you open it. I'm just going to give this column here sample number. It's not important, it's just sort of how many samples we have. Factory just tells us which factory the measurement is from. So later on you'll find out that there's actually two factories, and we're going to look at both of them individually. But right now we're interested in column C3 and column C4, the measurement and the defective. So 0 means it's not defective, 1 means that it is defective. A defective means that the measurement is less than 1000 units, let's say. So let's just scroll through. There's one. That's case 47 is defective. Okay. So what we want to do here is, let's first off go back to summary, and we'll just have a quick look at this variable here, measurement. So I'm just going to select measurement there. It's actually already selected. So just select that. Okay. And what happens here is I get this summary report for measurement. The key things I'm looking at here, first off, it's nice to know that it's normally distributed. Okay, that's good. Okay, how do I know that? Well, the red line sort of matches up very well with the histogram underneath it, and also we got the p-value here for the Anderson-Darling test. It's not significant, it's greater than 0.05 or 0.05, and in that case we fail to reject the null hypothesis that the data the population from which the sample is drawn from is normally distributed. Bit of a mouthful there. Anyway, also what we're looking at down here below is a 95% confidence interval for the mean. So essentially what we're saying is, with 95% confidence, this is a very blunt interpretation. There's actually a proper interpretation of confidence interval. But essentially what we're saying is that the mean is, we're pretty sure that the mean is between 1000 and 2.6 and 1000 and 2.7. If just now, this is not part of this actual exercise, but if you just consider that mean is actually quite high by comparison to the target, and that means probably we're wasting a little bit of material, because we could probably make the machine a little bit more accurate to, as in closer to the target of 1001. That's a different story. Now, just looking at this here, what we're going to sort of see here is that quite a lot, just where quite a lot of this histogram of the data or the measurements seem to be less than 1000. Okay, just looking at that there's a big chunk here to the left hand side of that 1000 mark. Okay, so I'm not too happy about this. So what I'm going to do here is actually just sort of see exactly how many, because it looks like it's way more than 2%. So I'm going to go to stat, I'm going to go to tables, I'm going to go to tally, and that's has it there ready. Defective, so the number of the tally of defective components. Let's click OK on that. So seemingly the 0 means not defective, and we only have 93.86% is not defective. 1 means defective, and that means that we have a it's a sort of, that's not great at all, to be honest with you. So 6% is much higher than 2%. Okay, right, what we're going to do here is look at hypothesis testing. Okay, now remember, this is just a sample. It's a very large sample. There's actually 5,000 items in this data in this sample, but it's a sample. So quite often what you might find is that other samples are not quite so large. Now, anyway, what we're going to do is carry out a couple of tests here. So I'm going to go to basic statistics, and we have one single sample. So I'm going to look at these two tests here, one sample Z test and one sample T test. Determine the mean of a sample, whether the mean of a sample, let's see if I can bring it back up there. Well, you can click on that yourself. It's sort of, but it actually does say that the population variance is known. Okay, this does not, the one underneath, determine the mean of a sample, whether the mean of a sample differs significantly from a hypothesized value. We'll use that one here today. So what I'm going to do here is click on that. Okay, and measurement. Okay, we're going to leave that top line alone. One or more samples each in a column. Okay, measurement is what we're working on. Okay, now down here I have this done already, but I'll just fill it in here. That we want to test is the hypothesized mean 1001. Okay, so okay, click on OK on that. We'll just sort of click OK on that for the time being, and then just sort of interpret what we'll see what we get. So here is what we have. This is what we have here. Now I have to go back over this a bit. So in the session pane, what we see is mu of the test of mu equals 1001. That's the population mean being 1001 versus the fact that, versus the hypothesis that the population mean is not equal to 1001. Okay, sorry. So it's just this here. Okay, so you might notice that we have a really low p-value. It actually is 0.00. Essentially, it's actually a smaller number than that, but it just sort of cuts out after 3 digits. Okay, so what does that mean actually? What are we looking at? Okay, so this is what we're actually looking at here. So this is what we call a two-tailed test. Okay, and again, mu equals 1001. That's to say the population mean measurement is equal to, forget the greater than. Sorry, I actually messed up those descriptions there. So it's equal to 1000, not equal to 1000. Okay, that's what we're looking at there. So forget the descriptions there. It means equal to 1001, not equal to 1001. So just let's click down here to sort of see how do we interpret that. If the p-value is less than 0.05, we reject the null hypothesis. That is to say, there's enough evidence to say that the null hypothesis is wrong. If the p-value is not less than 0.05, we fail to reject the null hypothesis. That is to say that there's not enough evidence to say the null hypothesis is wrong. Let's go back to Minitab there, just to keep that in your head there for a second. So the null hypothesis here, or the p-value here, is 0.05. In that case, we reject the null hypothesis. Remember, it's smaller than 0.05. Okay. Well, in this case, actually, well, okay, we'll just sort of stick with this for the time being. We'll reject the null hypothesis. There's actually different values you should use here, but I'm just going to use that you could use depending on different circumstances. But essentially, large or small is really what we're looking at here. In this case, we reject the null hypothesis. It's much smaller than 0.05 or any other threshold we're using. We could use, or we generally use. So in this case, we reject the null hypothesis that the true mean is 1001. Remember earlier on we sort of said that it's actually a bit higher. The true mean is, like, we're pretty sure it's between 1002.6 and 1002.7. Okay, so we don't think it's actually 1001. It's actually, it seems to be a little bit higher. Now, you know, really, we got a bit of a problem of wastage, but really, is it less than 1001? Okay, so essentially we might have a little bit of a problem with wastage, but ultimately, as long as it's greater than 1001, the true mean, we're sort of still happy. Okay, so the hypothesis test here, mu is greater than 1001, is our null hypothesis. That's to say that the population measurement mean is equal to or greater than 1001 versus the population mean is less than 1001. Now, if it's less than 1001, then we're in trouble. Alright, well, then there's a problem. Everything has to be sort of fixed, or we got a court case coming up or something like that. Okay, so what I'm going to do here is I'm going to close that down first off. I don't need that now. So what I'm going to do here is we're going to go back to our data. I have it there somewhere. We'll just keep going anyway. Stat, what we go to do is go to one sample t-test. Okay, now we're going to go down here to options. Okay, 95%. Okay, so the alternative hypothesis here is that this is what they call a two-tailed test. Mean is not equal to a hypothesized mean. We're going to use a different one here, the one just above it. Less than or equal to, or less than an hypothesized mean. So just the one above it there. Click on that. Now what we have is a one-tailed test. So let's click OK on that. Okay, there we go. So the one sample t-test. So test of mu is equal to 1001. Well, you could sort of infer greater than or equal to 1001 versus the alternative hypothesis that it's less than 1001. Okay? Now, looking at the p-value over here now, that's huge. 1. Okay? So essentially what we're saying here is that we fail to reject the null hypothesis. Okay? The null hypothesis that it's greater than or equal to is 1001. So there's nothing to worry about. We don't think that the true mean is less than 1000. Okay, so there's a bit of a wastage problem. We can talk about that at a different time. Essentially, we are not worried about the population mean being less than 1001. Now there's a second hypothesis we're going to look at, hypothesis test. Now, population proportion of defective components is less than 2%, less than or equal to 2%. If that is the case, we're happy enough. If the population proportion of defective components is greater than 2%, we've got to have a bit of a chat with some engineers. Okay, so let's go to that now. Essentially what we do here is we go to stat. Now remember the data is in there behind somewhere, but essentially what I've got to do is stat, go to basic statistics, and what I'm going to do is go down to this one sample proportion test. Okay. So essentially what I'm interested in here is click on that. I just have to click on that. It doesn't come up automatically. Click on defective, select that. Now what we're going to do is perform a hypothesis test. And I think I'm just going to put it in as 0.02. Okay. Hypothesized proportion, 0.02. Remember to do that specified as a proportion. Now options. Okay. So in this case what we're looking at is the other case. The alternative hypothesis is that the proportion is greater than 0.02. Okay? And so that's why we have it like that. Proportion is greater than 0.02. That's our hypothesized proportion. Click OK. Now, also what we might do is we talk about confidence level later on. That's just actually to sort of specify what type of confidence interval we're going to use. That's something for later on. Click OK and OK, and that's the test and confidence interval for one proportion of defective components. Test of p equals or less than or equal to really 0.02 versus p greater than or equal to 0.02. So it checks this out, and essentially what it says here is that we get a p-value there of, well, it reports it as 0.00. It really just means that it's an extremely small number. So in this case what we're going to do is we're going to reject the null hypothesis. Okay, we get a really small p-value. What we do is reject the null hypothesis. Essentially there's not enough evidence to support the notion that we're less than or equal to 2%. Okay, essentially it looks like we have a bit of a problem. Alright, so that's a quick introduction to one sample hypothesis tests. I'm going to call it a show.